Step-by-step procedure in setting up solar power. Common type of solar power system. Off-grid solar power used primarily in areas where no grid power is available. The setup is composed of solar panels, charge controller, and batteries. Another variant is hybrid off-grid. This setup is used where the grid is available. The energy harvested by the solar panels during the day is being used by the household appliances, and if there is a surplus energy, it is being fed back to the grid. This excess energy is recorded by the kilowatt-hour meter and is being deducted to the energy consumed from the grid at the end of the billing period, thereby reducing the energy consumption to a certain extent or even zero out the monthly electric bill. Common materials for solar power system. Solar panel, PV modules. Inverter. Batteries. Controller. Aluminum railings. DC wires/cable. AC wires/cable. Battery lugs. MC4 connectors. AC breakers. DC breakers. AC SPD. DC SPD. AC MCCB. DC MCCB. RSD, rapid shutdown device. Load requirements. Based from average monthly consumption. Get your billing statement that your local electric distribution utility sends you at every billing period. The more record, the more accurate would be the computations. Get the average monthly energy consumption. Two, based from actual load power consumption. List down all electrical appliance/load that will be powered up by the solar. Take note of the power rating in watts. Decide the maximum runtime of each appliance/load in hours. To calculate the energy needed, we will multiply the wattage of each appliance and the expected runtime. X. 10 watts x 10 hours equals 100 WHRS. Sizing of the solar panels needed. Get the result from the energy consumption, load requirements. 9.13 divided by solar insolation in HRS equals wattage of panels needed. (9.13 divided by 3.5 HRS equals 2.61 kilowatts, 2610 watts. So, we will be needing 2.61 kilowatts of solar panels. If we are going to get 545 watts panels, we need 5 PCS of this, 2,725 WP. Next is to determine the required area needed to fit 5 units of 545 watts solar panels. Right now I am using 0.25 kWatts/SQM as basis of my computation. Sizing of the solar panels needed counted. From the previous calculations, we were able to determine the size of the solar panels and roof area needed to set up a solar power in your home. Next is to determine the size or capacity of the inverter. This is basically straightforward since we are planning to set up a grid to set up. Just choose around 2.5 kilowatts or 3 kilowatts grid D inverter for this. Why 2.5 kilowatts or 3 kilowatts? Because the peak output of the solar panels is 2.61 kWp. If we get 3 kilowatts we could add more panels in the future and add additional appliance. Sizing and selection of the battery for lead acid. We needed few data for the following. Load requirements, energy consumption. Autonomy, number of days of operation without sun. Energy consumption equals 9.133 kilowatt-hour, 9,133 where, per day. Autonomy equals 1 day, usual choice because of battery cost. Battery equals 2x energy consumption divided by 12 v.2 is the multiplier that represents 50% depth of discharge for lead acid batteries. Equals 2x 9133 where divided by 12 v. Equals 1522.167 Ah. Determining the number of battery to be used. Equals 1522.167 Ah divided by 100 Ah equals 15.22 equals 16 PCS 12 V/100 Ah batteries. Equals 1522.167 Ah divided by 200 Ah equals 7.61 equals 8 PCS 12 V/200 Ah batteries. Sizing and selection of the battery for Leaf APO4. For 48-volt system, power wall. We needed few data for load requirements, energy consumption. Autonomy, number of days of operation without sun. Energy consumption equals 9.133 kilowatt-hour, 9,133 where, per day. Autonomy equals 1 day, usual choice because of battery cost. Battery equals 1.2x energy consumption divided by 48 v, 1.2 is the multiplier that represents 80% depth of discharge for lithium batteries. Equals 1.2x 9133 where divided by 48 v. Equals 228.325 Ah. Determining the number of battery to be used. Equals 228.325 Ah divided by 100 Ah equals 2.28 equals 2 PCS 48 V/100 Ah batteries. Equals 228.325 Ah divided by 200 Ah equals 1.14 equals 1 PC 48 V/200 Ah batteries. If you have question on this kindly post in the comments. Choosing the needed materials. For the on-grid/grid-to system, selection of the inverter is pretty straightforward. The inverter capacity must be equal or a little bit lower, around 10 to 15%. Then the peak power output of the solar array, solar panels installed. For the selection of the solar panels, the computed array size, capacity would be the basis. Just divide the peak capacity with that of solar capacity available from the solar store and you will get how many panel you need to buy. Choosing the needed materials. For the off-grid system, the inverter capacity will be determined by the largest power requirement of your appliance or load. If you are using motorized load, water pump, etc., the capacity of the inverter is 3 times the load requirement. Example, water pump running at 500 watts. The capacity of the inverter would be 1.5 kilowatts to 2 kilowatts transformer type inverter. The selection of the solar panels is the same in choosing solar panels for the grid-tied systems. Choosing the charge controller. Divide the total array capacity with the DC system voltage so that you can get the ampere rating of the charge controller. Always choose MPPT type controller. Example, 2,610 watts divided by 48 V equals 54.375 amps. From the given example you may use 60 amps to 80 amps charge controller. Installation. Always keep in mind that the optimal installation orientation of solar panels in the Philippines is 12 to 20 degrees due south. The orientation may also vary depending on your geographical location around the globe. To compensate for the losses, you may add 1 to 2 panels for every 12-panel array setup.